Hello guys, my name is Mike and this is the first ICODROPS interview in English. Today I have a very special guest. His name is Michael Egorov and he is a co-founder and CTO at Nucypher project. Hello Michael, how are you doing?
Hi, good.
Glad to hear it. By the way, in what city are you right now? As far as I know, you've been at Blockchain Connect conference. How it was?
Yeah, so I'm right now in Seattle, but Blockchain Connect was in San Francisco, and I also was at BPACE conference at Stanford at about the same time. And yeah, it was very nice. So on Blockchain Connect, there was a panel about privacy in blockchain, and it was more like on the data privacy side, and there was also a guy from Monero talking about privacy of transactions, and also the lady who worked as a prosecutor in cryptocurrency cases in the past, but now works in Coinbase. And it was very interesting to learn from them, especially in the backstage conversations. And also, I gave a tech talk at Stanford. That was also very nice, and lots of very interesting meetings over there.
So Michael, could you please introduce yourself to our audience and tell a little bit about your previous experience before Nucypher? I know that you have a really interesting background. You've graduated from the Moscow Institute of Physics and Technology, and as a scientist and physicist, you worked on the problems closely related to quantum computing and cryptography. Can you tell a little bit about this period of your life?
Indeed, yeah. So yes, I graduated Moscow Institute of Physics and Technology, and actually before finishing the last year, so I got a bachelor degree but not master's. I went to Australia to do a PhD in the area of cold atoms and Bose-Einstein condensates. Basically, there is one of the approaches in quantum computing is to use cold atoms. So maybe there is a connection here, and also our Bose-Einstein condensates actually could be used as qubits, although pretty slow. But I've got a very high coherence time over there, so there is some connection you could make to how quantum computers work. But at least it sparkled some thoughts about that. And after that, I worked as a postdoc. So PhD was at Swinburne University in Melbourne, and postdoc was at Monash, also in Melbourne area. And then I decided to go to the United States, thinking to start some startup. As an agent for that, to do that, I chose to basically get employed. So I got employed at LinkedIn, finding the job also in LinkedIn. So, well, LinkedIn is good for finding jobs in LinkedIn, apparently. Basically, the first 2 years in the US, I spent working in there and exploring opportunities around me.
Mike, why did you decide to quit science and start a career in LinkedIn?
Right. Well, I didn't necessarily fully quit science. The thing was that in science, to do some research, you actually need to struggle a lot to find funding for this research, and also there are some non-research activities like teaching you have to do. So I decided, why not try to work on the other side? Why not try to apply some scientific advances in practice and maybe fund someone else's research and form collaborations? And while having a scientific background, maybe it will be easier to establish these collaborations and basically get the things moving. And that's exactly what we are doing right now at Nucypher.
By the way, do you remember the moment when you first heard about Bitcoin and cryptocurrencies?
Yeah, so the first moment was sometime in 2012 when I was reading Linux Org Group forum. And I didn't pay much attention to it at that time. I looked again at it in 2013 when Bitcoin started going up. One of our students, when I was working as a postdoc, went to Europe, and he used Bitcoin to carry his money pretty much. So I guess that's why I kind of looked at it. And yeah, it appeared that right at the very peak in 2013, I bought a tiny bit of Bitcoin, and then I witnessed all the crash, Mt. Gox story, fun stuff like that. But I also actually mined quite a bit of, well, some cryptocurrencies using one single GPU, mining altcoins and switching to the most profitable. Well, learned a lot about altcoins and hashing algorithms, and also noticed Ethereum when it just was getting started by Vitalik. Although didn't invest on pre-sale, unfortunately. So yeah.
Okay, let's speak about Nucypher. And my first question is, why Nucypher? What does the name of the project mean?
So Nucypher means just a new cipher, new encryption algorithm. So we bring something new to encryption. That's kind of what the name implies. It doesn't imply anything about how it works, but just this brief message.
The first thing that caught my eye when I opened Nucypher's webpage was that there were more dots on your page than even on Polkadot's webpage. Is this some kind of competition, and aren't you afraid that they will sue you for this?
Yeah, no, well, actually, we didn't even think about Polkadot or anything special about dots. Dots were mostly to represent data when it's encrypted or not encrypted. It could be not dots, it could be squares, or it could be kind of some paper which you smash together, or puzzle. But, you know, it just happened to be dots in the design, that's it.
When and how did you meet your business partner, McLean Wilkinson, and who suggested to start the project?
Yeah, I met McLean at one of early Bitcoin developers meetups in 2014. Basically, we decided to work together on some interesting projects. Basically, at some point, we started Nucypher, but actually at the time it was 0DB. So we started with, originally we started with end-to-end encrypted database called 0DB. And basically after that, it smoothly came to what Nucypher is today.
Okay, the ICODROPS research group has been watching for Nucypher project for quite a long time. But for the general public, Nucypher was a little bit under the radar until not long ago. It seems to me that one of the main reasons that Nucypher is not that easy for understanding by an average person who is not IT specialist or blockchain expert. It's not like many consumer projects claiming to be Uber on blockchain or Airbnb on blockchain. Considering this, could you explain the main concept of Nucypher to me, like I'm 10 years old?
Yeah, so the main concept is basically enabling sharing data while it's encrypted. It's not really possible with traditional algorithms which you have today. So there are like symmetric block ciphers, there are some public key encryption algorithms, but they only public key encryption algorithms only enable person-to-person communication. And when you come to one-to-many or many-to-many communications, it doesn't really scale well. For example, if you wanted to share message, if you wanted to create a multi-user end-to-end encrypted group chat, like currently in Nucypher's group chat on Telegram, we have 10,000 people. If it was end-to-end encrypted, when you send a message, you would need to encrypt for every of those 10,000 people, which doesn't really scale well. Or imagine someone new joins and he wants to read history of end-to-end encrypted chat. Then somebody would have to encrypt all the history for that guy and stay online for that. That doesn't quite work well. And Nucypher actually can enable these things by allowing a third party to transform data to be encrypted for whoever needs it, if provided he has a permission, without actually seeing unencrypted data. This is called proxy re-encryption, the algorithm which allows that, and that's kind of the basis of what we do in Nucypher.
Okay, when it comes to analyzing any business project, in my opinion, one of the most important things is the team. I always want to know who are the people behind the project. Could you please tell me more about the Nucypher's team?
Sure. So I certainly told about myself. My co-founder, McLean Wilkinson, graduated University of North Carolina, and he worked in Morgan Stanley. It's a big bank in the United States, on mergers and acquisitions side. Pretty much, making economic models and analyzing companies which were to be acquired. And after that, he went to Silicon Valley to work, to find basically startup opportunities. And he's actually a pretty techy guy. So when I met him, I found that he's kind of programming in writing software in Vim, and also uses Vim type navigation in his browser. So pretty nerdy stuff. So basically, by seeing how he does that, I thought he might make a good co-founder. But anyway, that's, I guess, University of North Carolina and Morgan Stanley is pretty much about his background. We also have pretty good engineers in our team. We have Justin, who worked on Hendrix. It's a kind of Django-based web framework. We have John, who is a cryptographic engineer, and despite his young age, he's only a little bit above 20. He's actually already very experienced with cryptography and penetration testing. Also we have Kieran, who has a background pretty similar to Justin, and he's I actually usually choose people by their GitHub profiles rather than credentials. So if there are many open source projects they contribute to, or if I like their code, I choose them without actually looking at which companies they worked at or universities. We also have Sergey Zotov from Moscow, who currently works on our smart contracts, and he has pretty much Java and Scala background. He helped us to work on Kafka before, and now he's working on the smart contract side. Pretty talented engineer. And also, I guess very importantly, we have David Nunes from University of Malaga creating the split key re-encryption algorithm for us. And this is something which didn't exist before. I guess I probably should tell the story about David a little bit more in details. Back in 2016, when we've been working on ZeroDB, we included this sharing capability through proxy re-encryption. And we found some open source implementations of proxy re-encryption. A couple of algorithms for the simplest proxy re-encryption and for quantum safe proxy re-encryption were written by David Nunes. So we referred to his implementations and to his papers in our white paper, and he actually noticed that and approached us. And basically that's when collaboration started. So he helped us to create proxy re-encryption compatible with standardized algorithms such as ECIS. And right now he actually invented a split key threshold proxy re-encryption scheme, which allows to decentralized trust as to who is re-encrypting the data. Like traditionally, you trust some central server to re-encrypt, even though that server doesn't see the data, but the server can do a denial of service attack. And now we actually are able to split the trust so that you cannot even shut down one server and it breaks down, right? And this is actually pretty new, and he created that, and we basically do that through collaboration with his university. So that's I guess that kind of summarizes the technical side of the team. We also have some non-technical people helping us.
How unique are the technologies used by Nucypher, and how are you going to protect them? Is it possible that some other project may copy or modify these technologies to create Nucypher's competitor?
Yeah, well, they are free to do that because we are open source. But from my observations, if looking at projects like cryptocurrencies, there is a pretty strong network effect going on. So if people start using some project, they are not willing to fully switch to the other one, and the forks they capture maybe 10–20% of value. And I think forks actually even create a marketing effect. So if the project is getting forked, it's actually a good project, and people should look into that and use that. And for us, network effect is obviously the case because we have the network of miners. So more miners, or I should say stakers, are there, the more secure the network is. Oh, actually, about the team, I also forgot to mention our advisors, and I guess they're worth mentioning. There are two professors, Giuseppe Atenise, who is actually one of the fathers of proxy re-encryption. He invented, I think he invented the first proxy re-encryption algorithm, which can share data with public keys rather than with private keys. That's a very, very important step. And also we have Dave Evans from University of Virginia advising us, and he's a specialist in multi-party computation. Also, we have John Bentelman and Tony Bishop helping us on business side. John Bentelman is a serial entrepreneur. He worked on a company called Rainstore. It was the last company he worked on, and that company was doing backups, searchable backups for pretty much financial institutions. It was sold to Teradata, and also Tony Bishop actually engineered the infrastructure for Morgan Stanley, and I think right now he's working in Equinix.
Okay, and speaking about the competitors, who are your competitors right now, and what are the main differences between you and them, if you have any?
Right. Yeah. So I think first of all, the biggest competitor is the centralized approach of doing things, like trusting the central server to facilitate all the data sharing is basically the approach which is currently happening in the world. Whether you use, groups, Telegram groups are not encrypted, and that's actually not a coincidence. Making Telegram groups end-to-end encrypted without what we are doing would be actually pretty hard, because it wouldn't be very scalable or it wouldn't be very secure. I think Signal is trying to do encrypted groups, but they do hit this scalability problems, especially when it comes to allowing new users to read history in chats. Another set of competitors is encryption companies in the centralized world, such as RSA, probably most famous, or I probably also should mention a company called Voltage, which is doing data masking and tokenization, again for mostly financial institutions, or well, maybe also healthcare. And with centralized approaches, I should say that the biggest engine for those was not the actual security, but compliance. So government required all their records to be encrypted at rest and in transit, specifying a bunch of algorithms, and basically that's what these companies were mostly doing. The company called Voltage is actually interesting. Well, I guess they actually weren't acquired by HP. They're interesting because they introduced the new encryption algorithm for format-preserving encryption back in the day. It was new, it wasn't in the standard, and the biggest engine for what's happening in centralized world, at least where the most revenues are, is compliance. So they were of course, because the algorithm was new, they were not compliant. So how do you sell something needed for compliance when you're not compliant? It took them about 6 years to get into the list of compliant algorithms to actually fully take off. And that's obviously makes it very hard barrier to entry to enter the encryption market for startups. In decentralized world, encryption makes actually much more sense than in centralized world, because you don't want to trust any central server, and that's why we decided to do it for decentralized world. So our competitors in decentralized world, at least from my observations today, are those who do approaches of multi-party computation. And multi-party computation is basically a way to compute over encrypted data without revealing this data to the machines who do the computation. This approach, well, at least since our advisor Dave Evans is a specialist in multi-party computation, so we basically talked to him. We thought if we should go this route, and basically multi-party computation, it needs a lot of bandwidth when it's computing. Maybe to do a simple bitwise operation, it could need many gigabytes of data exchange. Of course, this doesn't scale really well. Oh yeah, also if you increase the number of participants in this multi-party computation system to make it more secure, it becomes even harder to scale. This is a very challenging thing. On the plus side for multi-party computation approaches, I should say that they allow much more than just data sharing. They allow to write something like a slow but private smart contracts. Smart contracts which work on private data without decrypting it, right? So there are two companies who pursue this approach. One is Enigma. They pivoted away from multi-party computation initially, but then they pivoted back. At least that's what it looks like. And also there is a company called Keep Network. They also try to create a decentralized multi-party computation system. So one of basically the major disadvantage to me for this multi-party computation is its speed. So it's very, very slow. It's still worth it if you want to do, if you don't require speed. For example, if you want, I don't know, if you want the smart contract to log into GoDaddy and, sell sell your domain for you, right? For example, that you probably would be able to do that with multi-party computation smart contracts, but it would probably take many minutes to actually do this transfer. This is okay for such a use case, but probably not okay for like chat application where it wouldn't be good to wait many minutes until you actually be able to decrypt the message. Of course, these multi-party computation approaches can be sped up by limiting their functionality, and I think that's what Keep is doing, but I'm not entirely sure. And also, multi-party computation approaches suffer from 50% attack. It doesn't have to be exactly 50%, but this is basically the attack when enough parties come together, they can totally decrypt all the data in the network. So pretty dangerous. And 50% attacks do happen. They did happen in on Litecoin, for example. They weren't used as attack, but you know, if one party can decrypt all of the data temporarily, it's actually pretty dangerous. In our case, 50% attack is not as dangerous. Probably if someone controls more than 50% of the network at some point, they probably will be able to do denial of service attack, like just to stop working, but they will not be able to decrypt data themselves.
Okay. And could you please tell a little bit about your business model?
Sure. So there are two kind of, since our company has centralized roots, we have two parts of our business model. One part is decentralized part. Decentralized part is more like is basically we're developing the network. We hold a little bit of our coins, and we use them for staking, for participating in our own network. This staking produces block rewards and also gets fees from those people who use the network. So we get a fraction of those because we have a fraction of coins, and that is how we earn money as a company. Another way is to help to apply our technology in more of a traditional companies. That's kind of another way to monetize the company. And in fact, we actually already have revenues from this way of monetization. Of course, also these traditional companies would probably sometimes want to try to touch the blockchain world, maybe in IoT space especially. And we definitely can help them with that, and to help them to solve the problem of how do you handle private data when working with public blockchains.
As I understand your business model, one of the most critical success factors for the project is the quantity and quality of partnerships. There are a number of partnerships officially announced at the moment. Can you please tell about them?
Right. Yeah. So there are two types of partnerships we have. One partnerships are with startups to allow new decentralized applications. I guess the most interesting part is collaborating with regards to medical data, like giving medical data back to the hands of the patients, and the patients can share data with doctors and revoke access when they need and stuff like that. There is one company in Europe, IRIO Network, I guess, or something. There is a company in Korea doing that, Mediblock, and there are two companies in the US who want to do the same thing. They approach this problem from different angles. Some want to store data in IPFS while encrypted. Some are a little bit more paranoid and want to store data on S3 and encrypt on top of that. But for all of them, Nucypher does work. Also, there are companies who want to sell to enable users to sell their personal data to advertisers, for example, autonomously. And one of these companies is Datum. So they collaborate with us to enable this kind of functionality. Also there are there is an IoT company called Spherity, which I think together with which collaborating with us and BigChainDB is basically doing something for sharing IoT data. Actually, there are decentralized databases who want to leverage our technology to share their data. I'm advising Bluezell, and they want to apply Nucypher for data sharing. But also, I'm helping them with telling them our experiences from building ZeroDB, because it was end-to-end encrypted database. They do want to bring encryption to their database too. And also, there are also two companies, Fluence and Walk, who build encrypted decentralized databases also. They all seem to be using slightly different approaches, so I'm actually very happy to see different pieces of infrastructure using different approaches, so that, you know, at least one will work, or maybe they will work better for like different use cases. So that's kind of the decentralized internet is being created after all.
There was some information on Twitter that Amazon and US government are interested in Nucypher's technology. Could you please comment on this?
Sure. So for that one, we actually participated in Decode 42 program in Washington, D.C. Where startups basically sell their technologies to the US government. So where selling means finding the right use cases, helping the US government to solve the problems they might be having. AWS is just sponsoring that program because they have the government cloud, and they do want government to use that. So, and for example, if for some use cases the AWS Gov is the government cloud is not yet usable, maybe with Nucypher it can be secure enough for government to use it. Basically, Amazon, in that tweet, Amazon just quoted McLean saying that we in Nucypher use proxy re-encryption. Well, at least, first of all, it's much easier to run POCs on Amazon, but what they see as most interesting for them is, of course, government using their cloud as much as possible.
Okay, speaking about the token sale, are you ready to deliver some more information on dates?
Right. Yeah. So yeah. So basically, the token sale will happen in.
If there will be token sale.
There will be a token sale, yes, and it will happen in early spring this year, right? I will not say the precise dates just yet, because we need to make sure our network can be up and running by the time of the token sale. Basically, the rule of thumb I've set for me how to determine this date is basically the date when we start the testnet plus 1 month. So as soon as we announce the testnet, you probably can know that 1 month from that you can expect the token sale.
Okay, great. Could you please speak a little bit more about the economic aspect of the token in Cipher?
Right. So the token, unlike many ICO projects, the main objective for the token is not to be used as a medium of exchange, but to be used to decentralize the trust in the system. So in a way, let's say if you have some node which is doing re-encryptions and it locks 10% of all the locked tokens, it means it gets 10% of trust in the system. Of course, 10% is probably too much. It probably will be more like 0.5% maximum, but still, their trust level to these nodes is proportional to the amount of stake they lock. So the more the stake you lock, the more job you get, the more fees you get, and actually the more block rewards you get. So all the inflation schedule will be distributed proportionally to the stake, to the miners, to those who lock the token. And mining, or I should say staking, works just like you run the node, you lock some tokens in there, you lock it for some time, let's say from 1 month to 1 year or possibly more, and your reward rate will depend on like how long you lock it for. So because we really prefer the stakers to be able to provide re-encryption services for as long as possible, we kind of favor the long stakers by them having a higher rewards rate.
Okay. And a little blitz in the end. Ledger or Trezor?
Well, I personally use a Ledger, and that's, well, this just has a more convenient form factor. And also there was this kind of vulnerability of Trezor, which is only relevant to the physical access, but still, well, I mean, they probably fixed it, but who knows, right? And yeah, the form factor is definitely, I like the memory stick form factor much better.
MetaMask or Parity?
Oh, yeah, well, that's a good question, because Parity is actually more like for a full node, right? So if you cannot have a full node by running MetaMask, but sometimes you don't have resources to run a full node, and then you cannot really use Parity. So this basically serves different purposes, I should say.
What will be the Bitcoin price on January 1st, 2019?
Bitcoin price? Yeah, it's a good question. I cannot really say precisely on Bitcoin price, but what I believe is that Bitcoin, relative to other coins, is, especially Ethereum, is a little bit overvalued. It does have a good network effect and good services using Bitcoin. Maybe that's why. But still, I believe that the kind of decline in Bitcoin fraction in all the markets will probably continue. But this doesn't necessarily mean the price drop. It probably, the price can still go up. I just think that probably some other coins, like maybe Ethereum, like maybe coins of some ICOs, are probably more interesting than Bitcoin at this time. But that's kind of, that's actually not surprising, because even if you look at the world of traditional large companies, investing in a large company is not as interesting as investing in startups, although startups are much more risky. And well, I think the same thing is with Bitcoin versus Ethereum versus ICOs.
Yeah. Let's assume that Satoshi Nakamoto is a real person and you could meet him. What 3 questions would you ask?
Well, first of all, I would probably ask if he did throw away keys for his early Bitcoins. That's, I guess, interests everyone. And I think actually it would be a very bullish signal for the market if he appears sometime and says, yeah, I did throw away the keys. Or maybe if he finds the keys and sends his Bitcoins to a burn address. But, well, another thing, I would actually ask him what purpose did he have when he created Bitcoin? Was it just an experiment, or maybe he wanted to start a crypto revolution and change everything and give monetary power back to the people? That I don't know, but he could indeed have philosophical reasons for starting Bitcoin. And yeah, well, the third question, I don't know if I would ask him or I would immediately see if I saw him, but I was always thinking that maybe Satoshi is not one person, maybe it's a group of people. So learning that would be also pretty interesting to me.
Okay, thank you, Michael. From all the ICODROPS team, I wish good luck to Nucypher project. To all our viewers, thank you for watching, and if you like this video, please subscribe to our channel, hit the bell button, and you will never miss the new one. Have a nice day and goodbye. Thank you.